Good evening, everyone. I'm Lokiredi Madhavi, pursuing computer science and engineering from IIT Chennai. Today, I'll be presenting about AI-driven cryptographic framework for intelligent threat detection in 6G networks. As we have, as we step into the era of 6G network, systems are become smarter, faster, and more interconnected, but also more vulnerable to complex cyber threats. My presentation will explain how artificial intelligence and cryptography together can form a powerful intelligence defense mechanism for next generations of 6G network and network security evaluation. The evaluation of 6G brings massive connectivity with billions of IoT devices connected globally. And unlike 5G, 6G will integrate AI natively into its architecture, supports ultra-low latency communication, and also handles trillions of data transactions every second. And but with the speed and scale overcomes a major challenge, that is security. Traditional cryptographic systems like AES or RSA may not meet the sub-million second response requirements. Moreover, the distributed architecture involving edge computing, cloud layers, and AI nodes exposes new vulnerabilities. That's why we need revolutionary cryptographic frameworks that are scalable, lightweight, and AI-assisted. Security is no longer optional. It's fundamental to 6G ecosystem. Why security is crucial in 6G means billions of the IoT devices and the smart devices are connected and it distributed in architecture that is edge plus cloud plus AI and also sensitive data transmission everywhere increase the risk of data theft, spoofing and cyber attacks. And when 6G security framework analysis let examine with SWOT analysis, that is strength, weakness, opportunities, and the threats of 6G network security. What are its strength means? Integration of AI for predictive threat detection and automated defenses. And its weaknesses are expanded attack vectors, due to billions of interconnected devices and heterogeneous networks, and its opportunities are development of quantum safe algorithms from the grounded up, ensuring long-term resilience, and its threats are develop the rise of quantum computing, which could break today's encryption within seconds. In short, we can say that while 6G enables advanced AI integration and connectivity, it also demands quantum resistance and adaptive security systems. Next, traditional versus AI-driven security. Traditional security tools like firewalls or intrusions detection systems are static. They rely on predefined rules and signatures which can't handle zero-day attacks or adaptive malware. So the proposed more approaches is AI-driven cryptographics, where AI predicts threats based on network behavior, and the cryptography secures communication dynamically, and the system learns and responds autonomously without human input. The architecture includes the encryption layer. It handles systematic or asymmetric cryptography, and AI threat detection engine continuously monitors the traffic, and blockchain ledger layer records and verify all the security events, and response layer automates defense actions. This layered approach transformation security from reactive to proactive. And AI techniques in frameworks. Several AI techniques strengthen this framework. Mainly, deep learning detects anomalies in network traffic, and reinforcement learning adapts responses based on the attack outcomes, and federated learning ensures privacy. Models are trained across multiple devices without sharing the raw data, and autoencoders learns normal network behavior and flag deviations instantly. These techniques work together to create a self-learning security system capable of evolving with emerging threats. Next, framework performing metrics. Now let's look at the performance metrics that defines the framework strength. First is quantum readiness. The system uses NIST approved post-quantum algorithms like CRYSTAL-Kyber for key exchange and crystal dilithium for digital signatures. These algorithms are designed to withstand quantum attacks. And next, network integration. This framework integrates with existing 5G infrastructures and ensures backward compatibility while also being scalable for massive IoT networks. Next is AI processing power. Advanced neural networks analyzes 10 terabytes of daily data, achieving 98% thread detection and 50 milliseconds response time and 99.9% as system uptime. Working mechanisms. Here, how the system works step by step are here. Data packets enter into the 6G network. The AI module analyzes the flow and predicts potential threats. If a threat is detected, the cryptographic keys are updated immediately. If the security logs are stored immutably on the blockchain, and responses actions such as isolation or blocking are triggered automatically. This closed feedback loop ensures continuously protecting and self-healing without manual interventions. And AI-driven evaluations. The development of this framework follows a logical timeline that is from 2024 to 25 foundation phase we call as. It builds AI-enhanced cryptographic primitives, and in 2025-26 we'll call as deployment phase. In this phase, large-scale implementation of intelligent threat detection systems across major telecommunication infrastructure, that is real-world rollout across telecom networks. In 2026-27, we'll call as quantum integration phase. In this phase, there will adoption of post-quantum algorithms. In 2027 to 2030, global standardization, that means making AI-driven cryptography is 60 security norm. By 2030, we can expect the global networks to rely on intelligent, quantum-safe, self-adaptive security systems. So by 2030, we may expect that we can get a 6G network. Security performance analysis. Enhanced security metrics, that is AI-driven cryptographic framework, demonstrates the performance across all the security parameters compared to traditional approaches, and also integrates machine learning algorithm with quantum resistant cryptography, and also it provides the unprecedented protection against both current and future threats. And organization implementing AI enhanced security report 87% of the reduction in successful cyber attacks and 94% improvement in threat detection accuracy. Here is the example pie chart for threat mitigation effectives, and 45% indicates the traditional security and 35% indicates the AI enhanced and 15% indicates the quantum safe and 5% indicates the advanced persistence. So, see, its architecture, it consists of multi-layer security stack and a cognitive security engine and a quantum safe infrastructure. We'll follow in this post-quantum cryptographic algorithm for long-term security, and also quantum random number generated for enhanced entropy and hybrid classes. AI-driven security framework components. It consists of intelligent monitoring, continuously AI-powered surveillance of network, traffic, device behavior, and system anomalies with 99.7% accuracy in threat detection identification. And next, adaptive cryptography. It's dynamically encrypt key management with quantum safe algorithms that evolve based on a threat landscape and network conditions. And predictive analytics will use machine learning models that detect the attack vectors and automatically parameters may be preempted. Next, autonomous response. Self-healing security systems that isolates the threats and apply the countermeasures and restore the normal operations without human interventions. Next, cost benefit challenges from this framework. Implementing this framework also yields strong economic benefits, that is 87% of reduction in successful cyber cost and 65% decreases in security operations overall head, and 94% is improvement in compliance audience results. However, this is the economic impact assessment for AI-driven cryptography frameworks and delivers returns on investment through reduced security instance and improved the operational efficiency and regulatory compliance for 4 years. For example, we have taken. And the next challenges. AI model bias and data poisoning attacks. It's highly computational cost for real-time analysis and also privacy issues in AI training model and compatibility with legacy networks. And next, real-world applications. The framework find real-world use in multiple domains such as smart cities and smart homes, ensure secure IoT communication, and autonomous vehicle supports V2X security and healthcare IoT and telemedicine protecting sensitivity data, and financial and blockchain systems provides fraud resistant transactions. And conclusion, integrating with quantum safe algorithms and also AI ethics and secures transparency and cross-border 6G network frameworks, autonomous self-healing networks. These are the future hope of using this AI-driven cryptography for 6G networks along with the quantum. And AI-driven cryptography is equals to future of 6G network and it intelligent, predictive, and self-learning defense and combines speed, privacy, and adaptability. Thank you all.